Hello everyone. So welcome to another Leetcode question. In this question, we will be discussing removing duplicates from a sorted array. So this is one of those questions where the question itself is very descriptive and we can figure out an algorithm to do the solution. Let's read the question very carefully here. So we are given an integer array called as nums sorted in non-decreasing order. Okay. So what does it mean by non-decreasing order? It's either increasing or the numbers are equal. And in that case, what we have to do, we have to remove the duplicates in place such that each unique element appears only once. Okay, we'll see later on what does this mean. And the relative order of elements should be kept as same. Okay, so the order of elements should be kept as same. So if we have something like 1, 2, 2 and 3, since these are duplicated elements, so this will condense down to 1. 1, 2. So what we'll have here? 1, 2 and then a 3, right? Because we need to remove the duplicate elements and make it appear only once. And we also is given the assumption that the result needs to be placed in first part of the array nums. Okay. So here we have 4 elements, and since after removing the duplicates we will have 3 elements, so only the first 3 are filled. We are not bothered about what we have after these 3 elements or after placing all the unique elements in the first part of the array. Okay. Now, if there are k elements after removing the duplicates, okay, then the first k elements of nums should hold the final result. That we already discussed. It does not matter what you leave beyond the first k elements, right? So it doesn't matter what we have after the first k position. And it's asked us that from the function we have to return this value k. Like how many unique elements are there, right, after placing the final result. And one more assumption is there is that we should not allocate any extra space for another array. So it's very clear in the question itself that we'll be using no auxiliary space and we have to do it in constant space, right? Let's go through the example to see what the input is and what we have to return. So we are given an array nums. In this we have 2 zeros, 3 ones, 2 twos, 2 threes and 1 4. After condensing it down to removing all the duplicates and moving all the unique elements in the first part of the array, we will have 1 0, 1 1, 1 2, 1 3 and 1 4. 1 0, 1 1, 1 2, 1 3 and 1 4. Okay, and the k will be 5, and this is the value that we have to return, and we should modify this nums only to contain these unique elements. Now let's discuss the intuition for this. Straight away we can think of it that we could use the 2 pointer to approach this problem. Now why we can use 2 pointer? It's been clear that if we have 2 pointer, one pointer will be sort of moving, iterating through the entire array, let's call it P2, and one P1 which will just hold the element at the index where it is unique, right? So if we have like 1, 2, 2, 2, 2 and then 3, so my P1 will stay here and P2 will always iterate through the array, and at P1 we will have the unique element. So in P1 we can have 1, then this P1 we will store the 2, and at that time my P2 will be here, right? So what's happening here is that my P2 is going through the entire array, ignoring the duplicates, but at P1 we'll only insert the element when P2 reaches the end of the duplicate sequence. Okay, then P2 will finally come here. In that case P1 will be here and this will be 3 now, and then P2 will come out and P1 will be here, at which we will end the array. Something like that we will try to do, right? So this is, in this case we are using actually 2 pointers, P1 and P2. Okay, now let's just look at the solution. Since we know that we have to do this in place, let's see how we'll do this. So let's call I as our second pointer, which is moving ahead and actually ignoring the duplicates, but the j is always at the position where the portion before j are all distinct elements. Okay, so this should be clear to us. Let's think about this for a moment. My I, when it is here, okay, when it is here, we have to find this position where the current element is not equal to the next element. Now why? if this element is not equal to the next element, if this 0 is not equal to the next element, what we can do, we can simply assign this value to the element at j position, and then we will increment both I, the second pointer, and the first pointer j, right? So what would happen with this is that we will have 1 0 at the initial position, and we will now be looking at the second portion of the array. Now, thinking of this way, let's just run through it once. So what we said is, we have 0 0 0 1 1 1. I'll just remove this quickly. Okay, let's remove this. And what we said is, we have our I here and we have our j here, right? So we said we will come at this position, my I will reach at this position, because at this position my this element is not equal to this element. And then we said we will assign this element to j position and will increment both I and we will increment j. Okay. Now we are at I. This element is equal to this element, so I will just move forward. This element is equal to this element, so I will just move forward. At this position, this element is not equal to this element. So what we have to do, we will assign this element to this guy, and then we'll move I1 forward and J1 forward, right? Because we have identified the end of that sequence where the elements are the same. Now we are here. Now at I, this element is equal to this element, so I will increase. But at this position, I is not equal, the element index I is not equal to the element at index at its next position, right? So in that case, we will assign this to the element at j position, which is here, and then we will move forward I and we will increase j. Now again, I will move forward, I'll just quickly go through it. At this position is not the same, so this will become 3 and I will move forward and j will move forward. Now at the last position, this is the position. At this case, since it is the last element, we will just simply assign it to the element at position j, and we will increment I and we will increment j. Okay. So my I, this will conclude our algorithm, and my I will come out of it, and j will be at the correct position, basically meaning that we have uniquely put our elements in the first part of the array. So this concludes our algorithm. Okay. Now discussing the time complexity and space complexity. So time complexity is obviously linear here because our I just iterating through the entire array once, and it was given in the question itself that we should not create any auxiliary space, and that's what we have done. No auxiliary space, so it is constant, and time complexity is linear. So we will now go through the solution walkthrough. We already discussed what the algorithm will look like. We have one pointer I, another pointer j. I is running through the entire array, and we have to find that position where this element is not equal to this element. Okay, so how will do this? We'll go through, since we have to compare this guy with the next guy, and my I is here, so I has to obviously oblige to the condition where I is less than array len minus 1, right? So if we have 5 length of array 1 2 3 4 5 0 1 2 3 4, and when my I is here, right, so 3 is less than 5 minus 1, which is 4. In this case it is correct, but at this condition it won't oblige to this condition for the last element, right? So that's why we have to do this. And while the value at the current index is equal to the element at next index, we will increase our I. And then we realized that once we have found this position where, let's say, let me just write it 1 1 and 2, at this position I, it is not equal to the next position, right? So what we'll do, let's, my j is here, we will assign it to this, so this will become 1, and my I will move forward, j will move forward. And again here, this is the last case, so this will be assigned to j, I will move forward and j will move forward. So we'll correctly return the j, and that's what we are doing. We are assigning it to j, we are incrementing both I and j, and then finally we can safely return j. So this concludes our algorithm for finding, removing the duplicates from sorted array. Thank you.